Welcome back. This is the third lesson recording for IM2, November 16th, 2020. Let's go through the rest of the Desmos exercise pretty quickly. Okay, sine of A. Sine of A, so the reference angle is right here. So sine of A is always opposite over hypotenuse. Opposite is here, hypotenuse here. So that's going to be 12 over 13. 12 over 13. Okay, this time cosine of B, the reference angle is here. Okay, cosine is adjacent. This is my adjacent. This is my hypotenuse. So that means that's cosine of B is also 12 over 13. Okay, so what about sine of B? Sine of B is, again, sine of B is opposite over hypotenuse. Opposite is 5. Hypotenuse is 13, so it's 5 over 13. Okay. Now, what about cosine of A? Cosine of A is adjacent over hypotenuse. It's also 5 over 13. Okay. Oops. Okay. So let's look for pattern in trig ratio. Okay. So just knowing what we just discovered, do you notice any numbers that are duplicated between sine ratio column to the cosine ratio column? Explain how they may be related. Okay, so if I look at 0.173, where do I see 0.173 in cosine? It's right there. Okay, so it's for 10 degrees. Its sine of 10 degrees is 0.173. So sine of 10 degrees is 0.173, but it is also cosine of 80 degrees. Okay, let's try another one. Okay, what about 0.342? Okay, that's sine of 20 degrees is 0.342. And what do you notice about 0.342? It occurs right here too. So it is for 70 degrees, but this time cosine of 70 degrees. So sine of 20 degrees is 0.342. Cosine of 70 degrees is 0.342. And you can keep matching them up like so. Okay, you have 0.5, 0.5. So 30 and 60 degrees and 40 and 50 degrees. Okay, so sine of 40 degrees is equal to cosine of 50 degrees. And we say sine of 30 degrees is equal to cosine of 60 degrees. Okay, what do you notice about the angles? 30 and 60, 40 and 50, they're complementary angles, aren't they? So the sine of an angle and cosine of its complementary angle is going to be always the same. So that's a conclusion that you should hopefully be drawing. Okay. All right. So look at the tangent ratio column this time. Okay. What is the starting value? Starting value, it's starting very small. Okay. Starting value is very small and ending value is very large. Okay, remember with sine and cosine, the biggest it got to was close to 1. It never got over that. But this seems to have no problem going over. In fact, 1 is right there. Okay, there's some below 1, but some definitely over 1. In fact, look at from 80 to 89 degrees, it increased by over tenfold. Okay? And what angle is tan theta is equal to 1? We just said that tan theta is equal to 1 at 45 degrees. Okay? And why do you think this is so? Well, think about it. When it's 45 degrees, what do we know about the side length? Okay? The opposite side, if this is x, whatever this value is, this is also going to be x because this is isosceles triangle, right? So that means x divided by x divided by x is just going to be 1 always. That is the reason at 45 degrees, it does not matter how big the side length are. The tangent of 45 degrees is always 1. Oops. Okay, so tangent of A. What's a tangent of A in this case? Tangent of A, we're looking for this angle here. Tangent is always opposite over adjacent. So opposite of adjacent is 12 over 5. 12 over 5, okay? Keep that number in your head. Okay, so then what is tangent of B? Tangent of B is 5 over 12. 5 over 12. Okay, so before it was 12 over 5, the previous one. So tangent of A was 12 over 5, but tangent of B is 5 over 12. What do you notice about the fractions or the ratio? They're reciprocal, they're flipped over version, aren't they? Okay, so for the complementary angles, the tangent ratios are reciprocal. Okay. All right, then the rest of the problems are extension problems, so I am going to leave it there. So let's quickly discuss what we discovered from our Desmos exercise. So one of the things we noticed about trig ratio is that for sine of theta is always opposite leg over hypotenuse length. So this is the opposite leg, and the hypotenuse is the red side. Let's just fix the hypotenuse to be 1. And if I just increase the angle measure, what happens? The opposite, and keep increasing like this, the opposite leg gets bigger, doesn't it? Okay, so it's starting from here and it just gets bigger. So opposite leg just gets bigger as the angles increase. And that is the reason sine of theta starts from 0 when there is no triangle whatsoever. So it's just a flat line. And then 1 degree or very, very close, even less than that, the opposite leg is very, very little. Okay. The hypotenuse is still 1. Okay. So it's really close to 1, but never quite 1. But then it gets um, yeah, the opposite leg is very, very small, so it's very close to 0. The sine of theta is close to 0. But then as the angle increases, the opposite side gets bigger, and so it increases until it is vertical. Okay, as angle increases, the sine value increases. However, the increase is not linear. So if I was to look at the just sine ratio, if I look at the difference between, I am just going to do between 10, 20, 30, 40, 50, 60, 70, 80 degrees. Okay, so if I look at it, the difference is 0.69, 0.158, 0.142. It is not the same difference, which means this is not a linear growth. And if you are actually graph it, as you can see, it's a curved growth. It's not a straight line. Okay, so it increases as not as a linear, but as a nonlinear function. All right, the second pattern that we should have noticed is that when you're given a triangle, right angle triangle, okay, and measure of angle A plus measure of angle B has to be equal to 90. Why? Because we already have a right angle here. So these two angles need to add to 90 in order for you to have triangle angle sum. Okay, so angle A and angle B are complementary, and hypotenuse is going to be 15. If hypotenuse is 15, then depending on whether we're talking about angle A or angle B as our reference angle, we're going to have different things. But let's consider sine of A. Sine of angle A is opposite of a hypotenuse. Sine of angle A is opposite of a hypotenuse, so that's going to be 12 over 15. What about cosine of B? Cosine of B is adjacent. Adjacent to angle B is this side, and hypotenuse is still the same. So it's also going to be 12 of 15. Okay, see, knowing that the complementary angles, okay, so angle A and angle B are complementary. So the complementary angles will give the same values when you have sine of A is going to be equal to cosine of A's complement, in which case is angle B. Okay, so if A and B are complementary, then sine of A is equal to cosine of B. That's the conclusion. Okay, and a third pattern you should have noticed is for cosine. Okay, so cosine is always adjacent over hypotenuse. So again, let's fix the hypotenuse to 1, and adjacent leg is at the bottom relative to this purple reference angle. Okay, so in the beginning, when the angle is really, really small, the purple is practically as long as the hypotenuse, but never quite long enough, right? But then as the angles increase, what happens? The adjacent side gets shorter and shorter until it's very close to zero. So as angle increases, the cosine value decreases. That's what you should have figured out. And then also 45 angle trig ratio. Sine of 45 degrees equal to cosine of 45 degrees, which is equal to 0.707 or root 2 over 2. And tangent of 45 is equal to 1. Okay, because it's an isosceles triangle. So if you have a 45 degrees triangle, then the ratio is going to be 1 over root 2, right? 1 over root 2 for sine or cosine. However, tangent of 45 is opposite over hypotenuse, opposite of adjacent, and these both sides are equal in length. That's what we know about 45-45 triangle. Okay, so because it's an isosceles triangle, it's always going to be true. Now, let's talk about more precise trig ratios. What if you are given a angle of 17.5? How would you figure out what x is? Well, it's close to 17, so we can't just say it's 17, or it's in between. So how would we do that? Well, we use the calculator, and we haven't introduced it up till now, but calculator, the sine, cosine, and tangent is right there. And to get to the inverse, you just need to press second. And I will show how to use these buttons in class. One thing you need to make sure is that to set the degree not to radians, but it should be to degree. Okay, so do not press this red. All right, so quick announcements about the Unit 5 test next class. Please pause the video and read the announcements. And then there's also a summary review notes that I'm providing for you that hopefully will help you remember the key things. And then finally, the review packet for homework is about 1 hour's worth of work on Canvas. Okay, have a great day.